In this fifth lesson on finance, we're going to look at the difference between nominal and effective interest rates. Now, an effective interest rate is when the quoted period and the compounding period are the same. So, for example, 12% per annum compounded annually. Okay, per annum compounded annually. Or you could have a situation where you had 2% per month compounded monthly. Effective interest rates. A nominal interest rate is when the quoted period and the compounding period are different. For example, you are talking about 12% per annum compounded monthly. Okay, so let's have a look at this sum over here. You've got R1,000 and it's invested for a year at a nominal interest rate of 12% per annum compounded monthly. Well, what would your future value be? You'd have your R1,000 invested at 12% per annum compounded monthly for 1 year, and you're going to compound monthly, so it's 1 times 12 is your exponent. Now my question is going to be, what would the effective interest rate be? In other words, this total amount of money over here, okay, which is going to work out to be 1126,83. I want to know, what would the effective rate of interest be if I just did a calculation once at the end of the year that would give me that same amount of money? So I'd be saying 1126,83 is equal to 1 plus my effective interest rate. It's only 1 year, and it's only compounded once a year. And that, of course, would have to be multiplied by my 1,000, my principal value, my apologies. So when we solve that equation, we're going to divide both sides by 1,000. So we get 1,126,83 is equal to 1 plus our effective interest rate. Our effective interest rate would be 0,12683. We usually quote our interest rate as a percentage, so it would be 12,683% per annum compounded annually. Now you can see that it really doesn't matter what your initial investment is, because what I'm really saying here is that 1 plus 0,12 over 12 to the power of 12 is going to land up being equal to 1 plus my effective interest rate in all to the raised to the power of 1. Okay, so that essentially gives us a formula that says 1 plus your effective interest rate equals 1 plus your nominal interest rate divided by your compounding period, raised to the power of whatever your compounding period is. Two little examples. Convert an interest rate of 15% per annum compounded monthly. In other words, I'm giving you the nominal interest rate and I'm asking for the effective interest rate. So my effective interest rate plus 1 is going to equal 1 plus 0,15. It's compounded monthly, raised to the power of 12. Okay, so when I work that out, 1 plus 0.15 divided by 12, all raised to the power of 12, is equal to 1,16075. My effective interest rate is just going to be 0,16075. As a percentage, it's 16,075%. That simply means but I can invest money at however much money at 15% per annum compounded monthly, or I can invest that same amount of money at 16,075% per annum compounded annually, and I will land up with exactly the same amount of money at the end. The second example, if the interest is quoted at 23% per annum, this time round I am giving you the effective interest rate, so we'd say 1 plus 0.23 is equal to 1 plus, and I'm looking now for my nominal interest rate, and it's compounded quarterly. So this is the equation that I have to solve. I have 1,23 is equal to 1 plus I over 4 to the power of 4. How do I get rid of a raised to the power of 4? I'm going to take the fourth root. Okay, so I'm going to take the fourth root of 1.23. And that is equal to 1 plus I over 4. Okay, equals, I want to subtract 1 from both sides. And I get that 0,053116 is equal to I over 4. Multiply both sides by 4. And my nominal interest rate is equal to 0,21246, which is the same as 21,246% per annum compounded 4 times a year, quarterly.